As the global demand for high-quality seafood surges, the aquaculture industry has emerged as the fastest-growing food production sector and is responsible for over half of the world's seafood. This industry plays a critical role in feeding the growing population, especially as wild fisheries approach their maximum sustainable limits. In Vietnam, grouper farming is a key component of this success. It supports smallholder farms and local economies. However, this industry relies heavily on trash fish for feed, and this presents environmental and economic challenges. So we must find a way to ensure that this vital industry grows sustainably while also protecting our oceans and our livelihoods.
This project's really designed around improving sustainable growth of grouper aquaculture for Australia and for Vietnam. So we're working with the Australian Centre for International Agricultural Research that does research for Australian companies, but also for international companies in developing areas to increase profitability and sustainability for industries, for smallholders and small businesses in both countries.
As wild fisheries reach their maximum sustainable limits, the aquaculture industry has become one of the cornerstone pieces in helping us reach the global food security demands. This increasingly vital industry is going to be responsible for roughly 2/3 of the global seafood production by 2030. Unlike terrestrial agriculture, high-value aquaculture predominantly involves carnivorous species, which require specific diets with high nutritional demands. The rapid growth of this sector has intensified the search and the focus on new species for aquaculture, such as giant grouper. Vietnam has emerged as a leader in grouper farming, driven by the species' rapid growth rate, large size, and high market demand. This industry is largely composed of small-scale farmers whose cash flow and profit margins dictate their livelihoods. Feed costs are estimated to account for roughly 90% of grouper production costs. Currently, the most cost-effective method for these small enterprises is using trash fish as feed for the grouper. With the recent introduction of giant grouper to the sector, there's still many knowledge gaps in the nutritional requirements of formulated feeds. This leaves essentially two options: high-cost formulated pellets with unsatisfactory results for the species, or trash fish, which are the most affordable and quickest feeding method. However, the use of trash fish presents environmental problems that lead to poor water quality and disease. And the high demand for trash fish causes significant price increases, leading to increased overfishing to meet these demands. This, in turn, puts considerable pressure on the marine life and results in great environmental impacts. The Sustainable Grouper Aquaculture Initiative is dedicated in closing the knowledge gaps in giant grouper nutrition and formulated feeds by introducing innovative practices that balance both profit and environmental stewardship. Ultimately, we aim to ensure the long-term viability of giant grouper farming whilst prioritizing the sustainability of marine ecosystems.
So this project aims to develop feeds for grouper. In doing so, we hope to shift the industry from heavily relying on wild-caught trash fish to a more sustainable alternative that can drive production in a more efficient way. But in order to do that, we have to work on the consumer acceptance of a different type of feed. So we're integrating our project between nutritional requirements, the use of that feed in the industry, and in the middle of that supply chain, we've got the feed companies embedded in the project to ensure implementation. We further want to have an impact on hatchery technologies to improve the robustness of fingerlings and the fact that they're weaned before going out into the industry and ready to accept the pelleted feed rather than trash fish. Altogether, this is going to improve the sustainability of the industry and prime it for sustainable growth. To achieve the aims of this project, we've got 4 main areas of investigation specifically with giant grouper. We're looking at pigmentation and colour of the skin. We're looking at minerals to ensure healthy, strong bones that are well formed. We're looking at starch levels in order to make the feed effectively while still optimising health and performance of the animal. And finally, we're looking at feed management to bring it all together and to give good advice on how to feed them.
Optimizing feed management is crucial for both economic and environmental sustainability. Since feed is the largest operational cost in aquaculture, poor management can lead to feed wastage, higher costs, and environmental pollution. Improving feeding practices can reduce feed waste, improve healthier fish growth, and contribute to a more sustainable and profitable production system. The research uses visual and acoustic tools like GoPros and hydrophones to monitor fish feeding behavior. This research compares the feeding behavior of juvenile giant groupers fed floating feed versus sinking feed, and tracks their feeding intensity under different satiation conditions to identify key behavioral signals associated with satiation. These findings contribute to optimizing feed input rates, reducing waste, and refining the feeding strategies for more sustainable and profitable grouper aquaculture.
Aquaculture often resulted in poor coloration of flesh and skin of fish. This turned out to be one of the key attributes valued by customers who consider appearance as an indication of high-quality products. An improvement in coloration will lead to higher market value. Skin pigmentation in giant groupers is essential for both biological functions and economic value. It supports vital processes such as camouflage, communication, and thermoregulation. In aquaculture, good coloration is linked directly to a higher market value, as customers associate vibrant colors with high quality. On the other hand, poor coloration common in farmed fish can reduce their market appeal and economic return, making pigmentation a key factor in commercial success. The research program focuses on enhancing pigmentation through dietary formulations and environmental settings. It tests different diets with carotenoids such as astaxanthin and lutein to boost yellow coloration of giant groupers. Additionally, the study explores how environmental stressors such as transportation affect on the pigmentation and stress responses. The comprehensive approach aims to optimize both diet and environmental settings to better pigmentation and overall fish quality.
Because this species is novel in terms of aquaculture, the study of giant grouper nutritional requirement plays an important role in the development of feed formulation. Determining the nutritional requirement of giant grouper is very crucial because it improving the growth, preventing the bone deformities and also improve the overall health of giant grouper. Proper nutritional balance is very important, like particularly for phosphorus, zinc and vitamin C, because it enhances feed efficiency, reduce cost and minimizing the environmental impact like eutrophication. This research is vital for creating more sustainable and profitable aquaculture practice, especially for high valued species as giant grouper, which is still undeveloped for commercial farming. So I divided my project in 4 chapters, including the environmental phosphorus, comparing the plant and animals raw materials, and also the role of vitamin C and zinc in bone health. This finding will offer actionable insight for optimizing giant grouper feed formulation, leading to better growth, reducing deformities and higher economic returns.
Starch is important in fish diet, such as giant grouper, because it serves as a cost-effective energy source and a binder that can improve pellet cohesion and water stability. It also helps to lower operation costs by replacing expensive ingredients. However, poor digestion in carnivorous fish can lead to the growth and health issues if it is used in high level. Because giant grouper being carnivorous fish, so it is struggle to digest starch efficiency. So my project aims to investigate the effect of different types of starch, such as tapioca, cornstarch, and wheat starch, at 2 levels, around 10% and 50%, and at 3 different gelatinization degrees on the growth and overall health of giant grouper. I will measure some key parameters such as growth performance, intestinal health, intestinal short chain fatty acid, and digestive enzyme activity. So I also, by identifying the ways to reduce the negative impact of the starch on giant groupers, my study aims to enhance feed formulations, ultimately improve the growth and overall health of grouper in aquaculture settings.
At the end of this project, we essentially want to be able to make more with less. We want to be able to use less feed and less feed resources in order to more efficiently and more quickly grow very high quality fish. The outcomes of that will result in more profitability across the supply chain, higher sustainability of resource use, less pollution, and then a lot of those smallholders that exist in Vietnam will be able to be more profitable and grow their businesses so that they can have more community benefits across the country.